Welcome, everyone. Today, we're jumping right into a comprehensive explainer on Chapter 6, ICT Applications. We're going to unpack how information and communication technology acts as the invisible wiring of our modern society. We're talking about everything from the way we chat with friends on our phones, all the way to how we engineer massive suspension bridges. It's a huge topic, so let's get into it.
To cover this vast digital landscape, we've broken things down into 5 key areas. 1. Communication and booking systems. 2. Retail and banking transactions. 3. Modeling and control systems. 4. Recognition and satellite tech. And 5. Expert systems and medicine.
Let's kick things off with Section 1, Communication and Booking Systems, Connecting the World.
So we use ICT to communicate in so many ways now, right? Think digital newsletters, posters, e-publications, multimedia websites, you name it. But a really prime example of this evolution is mobile communications, like VoIP or Voice over IP. When companies upgrade from traditional landlines to VoIP, they get some seriously powerful features. The calls are way cheaper, you can stream live video, and you can even share your screen. But, and this is a big but, you're trading the standalone reliability of an old-school copper wire for a system that completely relies on network stability. Basically, if your internet drops, your call drops. And that heavy reliance on bandwidth is exactly what drives media streaming too. The true magic here is real-time delivery. Instead of sitting there waiting for massive video or audio files to download and save to your local device, media streaming just processes the data continuously as it arrives. This is a total game changer because it saves a tremendous amount of storage space on your phone or laptop, but again, it absolutely requires a constant, stable internet connection to keep things from buffering.
Now, this real-time connectivity has completely revolutionized booking systems. Whether you're booking flights, concert tickets, or a spot at a major sports event, online booking fundamentally solves that awful manual error of double booking. Why? Because the database updates globally the exact second a seat is selected. Plus, it's available 24/7, and you get immediate confirmation. The flip side, though, is that setting this up requires some really expensive hardware. And if the system crashes, well, your entire booking operation just grinds to a halt.
All right, moving right along to Section 2, Retail and Banking Transactions, the Digital Economy.
While older systems like manual check clearing are becoming increasingly automated, modern banking systems rely on a highly intricate step-by-step communication handshake. Take ATMs, for instance. When you use one to print a mini-statement, you insert your card, the system reads your details, and you enter your PIN. But then, the machine has to securely communicate with the bank's central computer. The bank verifies your identity, checks your funds, creates the statement data, and then sends it all the way back to be printed. It's like a rapid-fire digital conversation.
And similarly, EFTPS, that's electronic funds transfer at point of sale, relies on this exact same sequential logic for everyday credit and debit transactions. You tap or insert your card, the details fly over the network to the bank, your PIN or biometric data is checked, the bank ensures you actually have the money, executes the electronic transfer, and finally sends an authorization code back to the store's receipt printer. All of this happens in literally milliseconds.
Of course, to protect these high-speed financial transactions, banks absolutely have to deploy multiple layers of security. Encryption is vital here. It basically scrambles the data using a complex key before it travels over the network, making it completely unreadable if someone intercepts it. Then you have biometric data, like your fingerprint or an iris scan, which ensures the physical user is genuine. It's incredibly difficult to fake. And the chip and PIN system? That stores your data on a secure microchip, which is significantly harder to clone than those old magnetic stripes.
For retail, the digital economy has been a massive shift. E-commerce means a 24/7 operation with vastly lower overhead costs compared to running physical POS terminals and managing complex warehouse stock control on the high street. But let's look at the trade-offs for the customer. You've got the security and fraud risks we just talked about, the inability to physically inspect goods before buying them, and of course the inevitable wait times for delivery.
Okay, let's dive into Section 3, Modeling and Control Systems, Simulating and Automating Reality.
So we use computer modeling applications for so many things today, tracking personal finance, simulating flood management, traffic management, and even weather forecasting. In engineering, before a single brick is laid, massive mathematical models are used to test structural designs, like for a bridge or a building. By inputting physical laws and material properties, engineers can simulate extreme conditions, think high winds or heavy traffic loads, just to ensure a bridge won't collapse, all safely within a digital environment.
Now, this brings up a really fascinating double-edged sword with computer modeling. On one hand, yes, it saves millions of dollars and potentially human lives because it's so much safer and cheaper than building physical prototypes. It allows scientists to ask endless what-if scenarios. However, the major drawback is that a model is literally only as good as the data entered into it. If there are programming errors or missed variables, your results will be completely skewed and unrealistic.
Moving from digital simulations to physical action, we enter the realm of computer-controlled systems in manufacturing and production line control. Look at these computer-controlled robotic arms. They don't just move blindly. They are equipped with input devices like light sensors, pressure sensors, and video cameras. The computer processes all this sensor data to execute manufacturing tasks like welding or painting a car with just absolute pinpoint precision.
While robots completely revolutionize manufacturing by working tirelessly 24/7 without fatigue, even in dangerous conditions filled with hazardous chemicals, we have to consider the downsides. The initial setup and maintenance costs are astronomical, and crucially, they cause significant job displacement for manual workers. Honestly, we even see this push for automation creeping into administration now, like with school management systems automating student registration, tracking daily attendance, and assisting with computer-aided learning.
Next up, Section 4, Recognition and Satellite Tech, Tracking and Locating.
We interact with recognition systems all the time. We use optical mark recognition, or OMR, for grading tests, OCR for scanning text, RFID and NFC chips for contactless payments, and biometrics like retina recognition. But one of the most fascinating is automatic number plate recognition, or ANPR. ANPR systems use specialized sensors and infrared cameras to capture high-contrast images of a car's license plate instantly as it passes by. Then, optical character recognition software actually extracts the text from that image.
And this simple recognition technology scales up to manage entire smart traffic systems. It automates everything from lifting a barrier in a private parking lot to enhancing security and preventing unauthorized access by cross-referencing plates against police databases. On a citywide level, ANPR is used to analyze driver behavior and route choices for urban planning and to automatically administer inner-city congestion charging systems, seamlessly billing drivers as they go.
Now, moving from the street level all the way up to orbit with satellite systems. Your Global Positioning System, or GPS, identifies your exact start and end location by receiving signals from multiple satellites. It then systematically compares possible routes using downloaded GIS, or Geographic Information Systems map data, cross-references live traffic conditions via media communication channels, and calculates the distance and time. It constantly recalculates to select the quickest or shortest route, giving you those familiar turn-by-turn directions. For our final section, let's explore Section 5, Expert Systems and Medicine, Intelligent Diagnostics. Think of an expert system as a digital brain. It's a highly specialized computer program designed to simulate the judgment and behavior of a human or an organization that has expert knowledge in a particular field. Whether it is prospecting for valuable minerals underground, scheduling incredibly complex delivery routes, or diagnosing human illnesses, these systems process facts and rules to reach a logical conclusion. To make this digital brain work, 5 distinct core components have to be meticulously designed. First, the user interface, which is how the user actually inputs symptoms or answers questions. Next, the knowledge base, which is the massive database of accumulated facts. Then, the rules base, containing the logical if-then connections. The true heart of it all is the inference engine. That's the reasoning mechanism that searches the data and cross-references the rules against the facts. And finally, the explanation system, which justifies the final conclusion to the user, so they can actually trust the result.
By analyzing vast databases of digital patient records and following these exact steps, a medical expert system can quickly narrow down a patient's symptoms to a highly probable illness. The system presents an interactive screen, asks targeted yes/no questions, and the user inputs their responses. Then, the inference engine churns through that medical knowledge base using the rules. It outputs the probabilities of different diagnoses, and the explanation system shows its reasoning. This gives doctors a really powerful, data-driven second opinion.
From the ATMs we trust with our money to the complex computer models that protect our cities from floods, ICT applications are deeply, deeply embedded into the fabric of our everyday existence. As 3D printing customizes our medicine and algorithms plan our daily routes, I'll leave you with this question. Which ICT application do you think will transform your life next? Thanks for joining me on this explainer.